Hi everyone, and welcome to this video about surface areas and volumes of solids. Before I begin the content of this video, please remember to like and subscribe if you enjoyed this video, and if you have any questions or comments, please leave them down below in the comment section. I'll get around to answering you, and if you would like me to make a video on a topic, then please let me know about that as well. Let's start with one of the simplest solid shapes, and that is the cuboid. Now, cuboid has 6 rectangular faces, so we can see the 3 front-facing ones here. If I add in the dotted lines to demonstrate the hidden faces, you can see that there's one to the left, one behind, and one underneath. So in order to work out the volume of our cuboid, this is very simple. What we're going to do is do the base of that front-facing rectangle times by the height of that front-facing rectangle, and then the depth of the shape. So for the volume, what I'm going to be doing is A times B times C. Now for the surface area of the cuboid, it's also very simple, but an easier way to think about it is if we just open out the cuboid into what we call the net. So the net is like the deconstructed version of the 3D shape. We can imagine it as flattening out a cardboard box, perhaps. So here you can see that I've drawn out the net of this cuboid on the left-hand side. It's not to scale, it's just to give you an idea of what's going on. So we can see that this length here is going to be B, this length here is going to correspond to A, and this length at the bottom here to correspond to C. Now, of course, these are all sets of parallel lines, so we can easily work out the area of each of these rectangles. So for this bottom one here, we know this is going to be A times C. For this one, it will be C times B. For this one, C times A again. And for this one, C times B. And hopefully you can see what I need to do is A times C plus C times B plus B times A, except I'm doing all of that twice. So this was B times C, C times A times B, and all of those are doubled up again. So I'm just going to put that in brackets and times it by 2. So that's the surface area and the volume of a cuboid. So let's move on to prisms. Prisms are a group of 3D objects in which the cross-section is the same all along the length of the object. So the cross-section that I'm referring to is this face at the end of the prism. You can see that the front face is identical to the rear face of the prism. So it doesn't matter where along my prism I cut downwards, the shape that I'm going to get, if I'm cutting parallel to the end face, is going to be identical to my end cross-section. Now the prism has a second measurement, and that is the length of the prism. So going from one side of it to the other, this will be called the length. And in order to work out the volume of our prism, well, it's very simple. We just do the end cross-section area, and we multiply that by the length of our prism. Now, of course, with an irregular shaped prism like this, the area of my cross-section is not a regular shape that I can work out the surface area of easily. We wouldn't be expected to work out the surface area of a prism like this. So just need to know what the volume is. We might get questions where we get more regular prisms, and these have their own special names. We can see on the left we've got the cross-section of the prism to be a square, in the middle a triangle, and on the right a circle. And so they have their own names. This one is a cuboid, so we've actually already done this shape, it's quite a standard one. This next one is a triangular-based prism, and the final one we know this as a cylinder. So for these shapes we might be expected to work out the cross-sectional area and then work out the volume. We also might be expected to find the surface area of all of these shapes. However, we'll have a look at that in a second. It breaks down to opening it up, finding the net. If we find the net, these are all standard shapes anyway. So for our triangular-based prism, we've not looked at volume or surface area yet. For the cuboid we have. Let's look at this example together then. So to work out the volume, we know that we need to find, as it is a prism, the surface area of that end face first. So that's going to be 4 times 3 times a half. So base times height times a half for a triangle. Then we're going to multiply by the length of the shape, so the other 20 centimeters, and we're going to find that that's 120 centimeters cubed. So this is, of course, the volume of our shape. Let's move on to the surface area. So what I'm going to do is I'm just going to break this shape down into its component parts. I'm going to try and imagine the net of this shape in my head just to make sure that I've got all of the faces. So I'm not going to redraw it, I'm just going to look at the diagram, see if I can pick out all of the faces. I'm just going to add a little tick after I've written down how to calculate the area of that face. I'm going to begin with the two ends, so the two triangles. So to work out the surface area of this, well, I've already done the surface area of the triangle. So that's a half times 4 times 3, and I have 2 of them. So let's times that by 2. I'm then going to add on the bottom face. So that's going to be 3 times 20. Then this front-facing slanted large face, which is going to be the diagonal of my triangle multiplied by 20. So to work out the diagonal of this right-angled triangle, I'm going to use Pythagoras. So 4 squared plus 3 squared, all square rooted. Multiply that by the length of that rectangle, which is 20. And finally, the rear face, which is going to be 4 times 20. Okay, and if I put all of those into my calculator, that works out to be 252 centimeters squared. It's an important point to note that surface area is always going to have units of centimeters squared. That's something you can use to check that you've got it right. And also the volume is going to have centimeters cubed. So you should have always 3 lengths multiplied together to work out volume. And in surface area calculations, you should only be multiplying 2 lengths at a time and then adding those products. Let's move on to our cylinder now. So we're going to work out the volume first. Now in order to do this, we know that our cylinder is just a prism. We're going to work out the base surface area first. It's a circle, so we're going to do pi r squared multiplied by the length, or in this case the height, of the cylinder. Okay, and that's going to give me 0.25 pi, or if I want to write this as a decimal, the answer will be 0.785 meters cubed. Okay, so now let's look at the surface area. I'm going to start off by working out the flat sides, or the circles, top and bottom. So again, I'm going to use pi r squared, and I know I'm going to need 2 of these. So that's going to give me a half pi. Now I'm going to work out this curved side of the cylinder. And it might look quite complicated, but if we actually open it out into the net of the cylinder, we'll see that this surface is in fact just a rectangle. Now, I don't know if you can imagine it, but let's say we slice downwards here and unfurl the sides, a little bit like the center of a toilet roll. If you cut vertically upwards and flattened it out, you'd see that the shape is in fact a rectangle. So the height of the rectangle is 1 meter, that's not going to change, but the length of this rectangle is going to be, if you think about it, the circumference of that bottom circle. In order to work out the circumference, I'm going to do 2 times 0.5 and then multiplied by pi. That's going to give me the circumference of the circle. Then we're going to times that by the height of the rectangle. Okay, and that's going to be my final answer. So that's just going to be pi. Let's add these together then. That's going to be 3 over 2 pi. And if we wanted that as a decimal, we could write it as 4.71 meters squared. Let's turn our attention to pyramids now. I have here an example of what we call a square-based pyramid. And the definition of a pyramid is any shape that has a polygon base. A polygon is just a multi-sided shape. And then triangular faces that meet at a point right at the top, which we call the apex. So remember, any polygon-sided base, it doesn't matter if it's a triangle, a square, a pentagon, as long as those sides are triangular and they all meet at the same point at the top, which we call the apex, that is defined as a pyramid. So in order to work out the volume of a pyramid, we first need to find something called the perpendicular height. And the way we find that is by going to the apex and drawing a line downwards till we meet the base. Now this line downwards should be drawn at 90 degrees. That's why it's called the perpendicular height to the base. Remember, we're not using any of these slanted sides of the shape. We're using the perpendicular height, so straight up from the base all the way up to the apex. And so the volume is very simple after we've worked out the perpendicular height. It's just going to be 1 over 3 multiplied by the base area. On this shape, my base area is going to be this square here. So once I've worked that out, I just need to multiply by the perpendicular height. Let's take a look at cones next. So I've labeled the height and the radius of the base of this cone already, because a cone is in fact just a special pyramid. So remembering the formula, we should just be doing a third times the base area times the perpendicular height. Now to work out the base area of a circle, we need the radius, that's why I've labeled it. So we're going to do a third times pi r squared, and then we're multiplying by the perpendicular height, which you can see I've drawn on. It's at 90 degrees to a radius, and it's coming straight down from the apex of the cone. For a cone, we'll also be expected to know how to calculate the surface area. So for the base of the cone, that's very simple. It's just a circle. We can just do pi times r squared. But for the curved, slanted side of the cone, this is a little bit harder to calculate. If we imagine it opened out, it's actually going to look like a sector of a circle. Now we have a formula that we must remember to work out this curved surface area, and that is pi r L. L is the slanted length of my cone. So measuring from the apex of the cone down to the side, to the circumference of the base, that is what we call the slant height. This is commonly labeled with the letter L. And the formula to work out that curved surface area is pi r L. The last shape that we're going to look at today is the sphere. For the sphere, we're going to need to be able to work out the surface area and the volume. These are just two formulae that I suggest you remember, but I do have a trick for remembering them. On the sphere, we're always going to be given the radius r. So this is from the very center of the sphere out to the outer surface. In order to work out the volume, I need to do 4 over 3 times pi times r cubed. And the trick that I use to remember this is I know that volumes are always going to have units of meters cubed or centimeters cubed, etc. So I need to have 3 lengths times together. Therefore, r must be cubed. And then you can see that the 3 is also on the bottom of the initial fraction. That's just a little trick that I use to remember it. The surface area is going to be 4 pi r squared. So we can see that because it's a surface area, we only have 2 lengths times together, radius times radius. Okay, that gives me units of meters squared or centimeters squared, etc. Let's look at an example question for a cone together. So here we have a shape called a frustum. This is in fact a cone with another cone subtracted away from it. Let's have a think about how to calculate this remaining volume. So let's work out initially the big cone's volume. To do that, I'm going to do 1/3 times the base surface area. To calculate that, I'm going to need to do 30 over 2. To find my radius, square that, and times by pi. Then I'm going to multiply by the perpendicular height of 40 centimeters. So that's going to work out the volume of my big cone. That works out to be 3000 pi. I'm going to leave it in exact form for now. I'm going to focus on the volume of the small cone. Now, in order to work this out, we're going to need to spot that in fact the small cone is similar to the large cone. Okay, I'm not sure if you've read the question and seen that there, a similar large cone. That means we can use ratios in order to work out the radius of the base of that small cone. We can see that the heights are in the ratio of 20 to 40, or in other words, 1 to 2. So we know if the base of the large one is 30 long, so we know if the base of the large cone is 30 centimeters, the base of the small cone will have to be 30 divided by 2, which is 15 centimeters. So let's do that calculation for the volume of the small cone now. That's going to be 1 over 3 times 15 over 2 squared, radius squared, of course, times by pi, times by the perpendicular height, which is 20. That's going to be 375 pi. So now we can work out the volume of the frustum, which is 3000 pi minus 375 pi, which is going to be 2625 pi. And if we want that in 3 significant figures, it will be 8250 centimeters squared. Let's have a look at one last example together. The solid shape is made from a cylinder and a hemisphere, and we're asked to work out the total surface area of the solid shape. So I'm going to break the shape down into surfaces that form the outer surface area. The first one is going to be the outer surface of this hemisphere on top. The second one is going to be the curved surface area of the cylinder. And the last one is going to be the bottom circular face. So well done if you spotted all three of those faces. In fact, we've already been told the curved surface area of the hemisphere is 32 pi centimeters squared. However, we've not got information about this bottom circle. So let's focus on that first. We're going to have to work backwards here in order to find the radius of this bottom circle in order to work out its area. If we know the curved surface area is 32 pi, we know the way to work out the curved surface area is the circumference of the bottom circle times by the height of the cylinder. So that's the height 10 there. And the way to work out the circumference of the bottom circle is 2 pi times r. Now we have an equation with r in it, and we can solve this equation to find that r is 1.6 centimeters. Now we have that, we can work out the area. 1.6 squared times by pi will be 64 over 25 pi centimeters squared. Okay, so we've worked out the bottom circle. Now it's time to do the top hemisphere. We can see that the base of the hemisphere is the same circle as below the cylinder, so the radius must be the same. We're going to use the fact that a hemisphere is half of a sphere. We're going to multiply a half by the surface area of a sphere, which is 4 pi r squared. And we know what the radius is, it's 1.6 from before. So this is going to work out the top surface of the hemisphere, which is 128 over 25 pi. Now we can add all of these together. So I've got my bottom circle plus the top hemisphere plus the curved surface area, and the final answer is 992 over 25 pi. Of course, not forgetting the units, centimeters squared. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.